Now let's talk about histograms. Actually, to be precise here, we're talking about graphical histograms. We're talking about drawing a chart, a graph that describes an interval frequency distribution. Alright, so let's use the following data set. Let's say that we have grades from a particular class, from a particular exam, and so the grade distribution, or the intervals for that, go as follows. And we'll let the last interval go through 100 and not be symmetrical with the others. And because to be symmetrical or consistent with the others, we'll just have to say less than 100. Alright, let's say that the frequencies for these intervals, these grades, were as follows: 6, 10, 12, and 4. Alright, and what we want is a graphical representation of that data. Let me squeeze it in here so that we can see this side by side. Along the horizontal axis, we will put tick marks here, 10 units wide. Hopefully this is all about the same. And on the vertical axis, we'll put frequencies. All right. So we'll go 2, 4, 6, 8, 10, 12. And in this case we'll have frequencies, but as we'll see later, we can't always chart the height as the frequencies. In this case we can, because each of these intervals have the same width. That is, each of these intervals are 10 units wide. Alright, so 60 to 70, we have a frequency of 6. Alright, so we have 6 items in here. 70 through 80, we have 10. Ten items. 80 through 90, I have 12. Alright, and 90 through 100, I have 4. Alright, and that is a histogram. And even though I haven't drawn it to scale, I'll show a more accurate rendition of that in a second. Here we have a histogram. We have the blocks touching each other. Alright, there are no holes, unless we have to have holes, unless we have no observations in a particular region, etc. If we have bars which are not touching and no intention of touching, that's called a bar chart, and it's not a histogram. This is a histogram. In the long run, we will have area of these blocks being equal to or is proportional to the frequency. Okay, in this case, the width of each of these blocks are all the same, so the height tells you the area. Alright, these numbers that I put here, 6, 10, 12, and 4, is the area. Okay, it's also the height though. Alright, let me, on the next page, do a better picture of that. Alright, and here I have a better rendition of that same chart. I need to do this so that when I show you some changes on this, then it becomes a little bit easier perhaps to handle. Alright, let's say though that I have actually more information, and that more information is as follows. Instead of the intervals I just had, let's say I had 60 through 70, which is the same, but then I had 70 through 75, 75 through less than 80, 80 through less than 85, 85 through less than 90, and then switch back to 10 unit interval, 90 to 100. And let's say the frequencies here, 6, 6, 4, 9, 3, 4. Alright, and previously we had these two intervals combined, of course, to 10, and we had these two intervals combined for 12. Alright, but now what we want is to draw this histogram and be faithful to the concept that it's the area of each of these blocks that's important. And now it's quite obvious that we have different widths. So let's be precise about that. The width of first interval is 10, next one 5, 5, 5, 5, and 10 again. So let's have a column for relative width, and this is arbitrary. So let's say if I say that the first interval has a relative width of 1, alright, so if 10 is equal to 1, then 5 is equal to a half. Okay, and then I can calculate the relative height that I need for my blocks to give me the areas. Okay, and this will be frequency divided by the relative width. Alright, so in the first, frequency is 6, relative width is 1, answer is 6. 6 divided by a half is 12. 4 divided by a half, 8. 9 divided by a half, 18. 3 divided by a half, 6. 4 divided by 1, 4. Alright, so these now will be the heights that I'll use in my chart. And don't have a whole lot of room here. Again, a 60, 70, 80, 90, 100. And of course we'll have midpoints in there. Then we want the relative heights, not the frequency. Over here, I need to go up to 18, and now I'm sort of pushing myself in terms of scale. 2, 4, 6, 8, 10, 12, 14, 16, 18. And again, I'll show a better rendition of this on the next page. Alright, so the first bar has a relative height of 6. So that's 60 through 70. There's 6 items. Next is a relative height of 12. That's 70 through 75. I have 6 items in there, and if I've drawn it to scale, which clearly is not, both these blocks will have the same area. 75 through 80 is a height of 8. But there are 4 items in that class. 80 through 85 has a height of 18. Goes all the way up here. Height of 18, but 9 items in that interval or class. 85 through 90, a height of 6. 3 items though in that class, and therefore there should be, this block here should have half the area of this either these two blocks, which have 6 items, and the last one is a width of 10, goes from 90 to 100 and has 4 items. Alright, so a height of 4. Alright, and that's the histogram now, making sure that it's the area of the blocks that contains the number of items. Alright, it's proportional to the number of items in the interval. Alright, so I'll now go to the next page and show you a better picture of this. Alright, and here again is that same picture done well. Alright, remember there are 6 items here, 6 here, 4, 9, 3, and 4. Alright, so these two blocks will have the same area, and these two blocks will have the same area. The 3, of course, will have half the area of the either blocks of the 2 6s over here. Now let me show you both the histograms together. Okay, and here we have both those histograms together. The first one with the red lines and the second one with the blue lines. And now that you can see them both together, you can see that these areas in both renditions are the same. Alright, so the area of this block, which is extra, in the second picture, is made up by a deficiency here. Okay, so in a sense, this got pushed over here, and the same thing as this got pushed over here. Alright, in the second chart we had more accurate data. It doesn't lead to a nicer picture or a more interesting picture, but here is the histograms for both, and you can see that they contain roughly the same information. If we had on the second histogram used heights, frequencies as heights, we would have had a very different picture. Very different. Okay, and that's the end of the story on histograms.